Hey there, and welcome to Phase 2, Section 2, where we're going to go ahead and make a larger level. But before we jump into Visual Studio, let's take a look at just what it is we're going to be doing. By the end of Section 2, we're going to have a larger level set up, and it's going to be complete with backgrounds, foregrounds, a play area, and a player character who can move around our level. Let's take a look-see first at the graphics that are going to be making up our level. So we've got three. We've got our background, our main background, our background, which is just kind of the far background, and our foreground item. Let's take a look-see at those. So here is our main background. I'll just zoom out so we can see the entire picture. It's pretty large. I think it's about 1680 by 10. That's the, what is it? How many pixels are you? There we go, 1769. So this here is pretty zoomed out. Let's zoom in a bit so we can take a look-see at what the camera can see. Or the camera in the game. It's only going to be able to see a little bit at a time, say this much here. So we can see here it's got a big white gap on the side, and that white gap there is because this is a PNG file and I wanted to go through and look at something else, a background item, which in our case is going to be this. But that there, why didn't we just stick it into the same picture? Well, there's a reason for that, and that's because the background, this one here, is going to move at the same steady speed that we want it to, but the background item, the far background, this one here, is going to be sitting in the top right-hand corner here. It does fit in perfectly fine, but as the player moves along, let's say they move along, let's zoom out a bit, this speed, we want the background item, the far background, to move just a little bit slower. And that one there gives the impression that it's got some depth going to it. As you're moving, if you just move your head sideways or looking at two things, things in the far background move a lot slower than those closer to you, directly where you are. Now, this second bit that I want to show is right here. It looks kind of ugly as it is right now. You'd have no idea that you were moving from an outside to an inside. You could even guess that you were moving from a garage to an inside. But the way we change that and give it a more of a, the way we give this more of a perception of depth is by giving in a foreground item, this brick wall here. Now what it does is it sits right here on this corner, and it covers about there to there and goes straight up to the top, and it covers off there, giving us a nice doorway that our player can walk through. So that's how the textures we're going to need for our level. So let's minimize him out the road and minimize that out the road. And let's look at what the classes we're going to be using for this one. We're going to need our Game 1 class, as usual. Inside our Game 1 class, we're going to load up 3 new textures. And they're for the level. And that's all we're going to be touching in our Game 1 class. The other one we're going to be touching is the level class. It's going to be extensively modified, pretty much redone from scratch from what we've got now, so it can accommodate all of the background items, the foreground items, the player and the play area and everything else like that it's going to need. Now we'll get into detail on it in just a moment. We're going to be introducing 3 new classes, the first one being the camera class. Now, it's taken straight from Precision. That was created back in XNA Extreme 101 Volume 2. So I'm not going to be going into detail as to how it works. I will code it and give a brief overview of it when we get in there, but nothing more than that. The Actor class. Now, this class here is the base class for our player and enemy type classes. It's not going to do much on its own. It will be there just so we can inherit from it and extend it into how we want. And to do that, we will be using our player class. And our player class, which inherits from actor. It kind of looks like this thing's inheriting from base, which is just wrong. Let's just say it is a base class. There we go. Rightio. And that's the ones we're going to be touching. So let's look at what we're going to be doing with all of these. So we'll hide this thing. New one. I got rid of my title and everything. Oh well. Let's look at the level class first. Rightio. So we are going to need to give it a bunch of things. First off, it's going to need to have a list of background items. There. background. Called backgrounds. We're also going to need to have a list of actors. Called actors. And we're going to need to have a play bounds and a stage bounds. These are going to be two rectangles. Let's put rectangle and stage bounds. Rightio, now let's look at what we're going to need, the methods. So we're going to need a public constructor, which in itself is not going to take in anything, and it will just do two things. We're just going to pseudocode everything. So instantiate the lists. That's right, I don't want to try and spell instantiate and get it wrong, so I'm going to say create. And we're going to set up the play bounds and stage bounds. We'll take a look see what they mean in just a moment. Going down here, we're going to need our update call. Which takes in our game time. Okay, so in here, we're going to loop through our actors list and update them all. In our case, we're only going to be having one in there to start off with, and that's our player. But we're going to set this up so that we can just add more and more into the actors list later on, or the enemies, and not have to worry about changing any code for that. After we've done the updating the actors list, we need to update the camera position. And we need to check if we need to increase the play area at all. Now, what do I mean by increase the play area? Well, our level is going to be rather large. As we saw before, the pixel width of it was 1,700 and how many was it? 1,769. That'll do. So it gets bigger as it goes. Nice. So 800 by 600 for our screen width only looks about, more screen dimensions, only views about this much here. Probably a bit more, but let's say for example's sake. There we go. It only draws this much. So our play area goes from here to here, and here to here. About that shaded space there. We don't want the player to be able to move outside here, off the screen, down too low or up too high. Let's look at the picture itself and take a look, see what I mean. Rightio. So our limits are the top limit there, and the bottom limit is at the tip of the fingers there. So that space there, that's the only spot we want our player moving up and down, and we never want them going off the sides of the screen like my mouse is doing. So increasing the play area, what we're just going to do is we're just going to put something in here which will be check for Q key. So if someone presses the Q key on the keyboard, that's going to move our play area a little bit more to the side. And by doing that, we need to update the camera position so that as the player can move off the side of the screen, the camera always shows them. And we'll take a look-see at that in the update camera method. So going down. So we need to have our draw call as well. Now our level takes in both sprite batch and Sprite Batch HUD. Now, all it does is loops through all of our background items list and draws them. And draws our actors. What else are we going to need? We need to have our other method here, which was in the update camera position, or which was in the update call, called update camera position, I should say. Moving down again. So private void. So what does it do? Well, it checks. Let's go back up to our diagram here. No, let's make a new diagram right where we are. Let's write what it says first. It checks if the player is to the right of the camera position, then we're going to move the camera a little bit. But at that same time, we're going to make sure that the camera isn't moving outside the play bounds itself. Diagram time. Let's put it underneath. That's right, I'm cheating with the shift key. Rightio, so there's our stage, 1769 pixels long, all the way across. I'm not going to write that in again. So let's put 800 by 600. Let's just say our screen is here. Now, our play bounds limits the player from moving to here. So what the camera does is it's always set in the middle, the camera position, and it checks, rightio, is my right-hand side on the current right-hand limit of the play area? Okay, yes it is. Well, that means I can't move any further past this line, or I can't move any further past right here, and the player is not allowed off the player is not allowed to move off the camera's what the camera can see here either. So if we press the Q key, our play bounds moves itself across by about 100, 200 pixels. We can define that one later when we're actually coding, and it moves it a little bit over to here. That was horrible. Pretend that's a straight line, please. So now, if our player is on to the right of the camera position right here, if the player is, let's say, at this spot, I'm a little player, little stick man. What the camera needs to do now is it's got to check, okay, well the player is to the right of my position, so that means I had better move myself over to the right because I want the player in the center of where I am, so that the player is not going to be running off screen, and we've got a way of making sure that as the player moves across the stage, the camera follows along. So he's going to move along there, and as it reaches that spot, the camera's going to reach there, and if you look at it there, it's only going to be about here, by my guesstimations, the camera's right-hand side. So it can still move a little bit further as the player moves again to the right of the camera. If it moves the player here, to the right, there's a little arrow. Looks horrible, I know. It doesn't even look like a stick man. Let's make him buff. Grr. I don't know. Yeah, they were supposed to be biceps. They just look horrible. Pretend it's a stick man. As he moves across here, well now the camera is reached its the play bounds, and it knows it can't go any further, so it limits the player from moving past this line as well. But if it was back here and the play bounds is over there, the player's allowed to move all the way over to there, and the camera's going to update itself as it goes along. But now that's going to mean that the camera's left-hand side is over here. The player is never, ever, ever allowed to go off the left-hand side of the screen. We're not allowed to go back. It's a side-scrolling beat-em-up where you only go to the right. You never go back. And that is the level class, I believe. No. Whoops. We need to put one in here. If we press the Q button, increase the play area, then we better have a method for that one, which is called add to play area. Public void now add to play area takes in an int, and we'll call that int how much, which is, you know, how much do you want to increase the play area by, and that says play bounds dot width, because it's a rectangle, plus equal to how much. And ends itself off there. Ooh, just on the bottom of the frame. And that's all we need for our level, I believe. So, let's scroll back up. Here we go. Now, our level class has a list of background items. Doesn't take it has a list. So let's clear this one here out and take a look-see at background item itself, because we didn't mention that before in our first one, did we? No, we didn't, because it's a struct. It's a struct of the level class. Now in this struct it needs to have a texture 2D for what its texture is. It needs to have a position to be drawing it at. It needs to have a speed to be moving at. And it needs to have a layer depth to be drawing at. So we don't need an update in our background item, but we do need to have a draw. Well, I guess we should look at the constructor first. If it's okay with you, background item. How's that to you? Rightio. So inside it needs to take in the constructor needs to take in all of the values. It needs to take in a texture, a position, a speed, that looks horrible, and a layer depth. And inside it, it just sets the values. Now it needs a draw. Inside draw, it takes in the sprite batch, the one that uses layer depth. So we're not giving it sprite batch HUD, just the normal sprite batch, which is set up in game 1 to use layer depths. So inside the draw call, this one here is nice and easy. We need to tell it to draw at the position it's at, so let's just write out the entire thing. Texture, and the position it's at is camera.getPosition, which takes in this position's value, and it times it by the speed. So what that's doing, if we look at the entire level, let's not look at the level, let's look at the actual textures themselves. So up here, as this one here moves across at the main one, moving at the full 1 speed, the background item, the far background item, this one here, we want it to move at a slower rate. So what we do is we tell it that its position is 0, 0 up here. So as the camera moves across at a certain speed, wherever determined by the player, that tells this one here, okay, well, you're supposed to be moving across at a slower rate. So by timesing its actual position, well, by its world position and camera position by speed, it gives it a much slower rate. And you'll see that happen in the actual game itself when we code in the next video. So after position, we're going to need to know how much of the texture to draw, which is null. Null meaning we'll use the full texture. We're going to draw them colored at white. Unless you wanted to change color as you went. No rotation. Vector 2.0, so we draw everything in the top left hand corner. And scale is going to be 1f. Sprite effects dot none, because we don't want to flip it around. And then we use the good old layer depth. So why did I write that entire thing out there, considering that is the method complete? Because it's a good way to transition into defining our layer depths for the entire level. So that's right here. Define layer depths, or level layer depths. Let's call it define layer level depth sections. So we're using, in our one, we're going to be using sprite sort mode dot back to front, I believe. Yeah, we are going to be using back to front. Well, what does that actually mean? Let's take a look-see at what our three things we're going to be drawing are. We've got our background items list and our actors list, but we want them drawn in the correct order. So let's write here backgrounds. Play area. And foregrounds. Taking a look-see back at the main texture, we've got our background, this one here. Our play area needs to be drawn on top of our background, our main background. So from there to there is our play area. And then we've got the ones we want drawn on top of the play area in the foreground. Like that one. Minimizing you, back to the normal one. So our layer depths areas are going to be like this. Our background, we're going to give it a range of 0.9 to 1. Our play area is going to have 0.4 to 0.6. And our foregrounds, we're going to give 0.1 to 0.2. So what does that mean? Back to front. Well, that means our back value is number 1 and our front value is 0. So it's going to take anything we draw in any order of the actual codes, but it's going to sort them all by what their layer depth was. So it'll sort them that way. And that's very important, because if we go back to our levels draw call, we're drawing the backgrounds and drawing the actors, but we need some of our actors to be drawn behind some of our background items. And that's where we use layer depths inside this project. Layer depths are very, very cool. And that'll sum up our struct for the background item and then off the level class. Moving on to, let's take a look-see at the actor class. As I said, this one is just going to be a base class that the player class can inherit from, but it does need some things in there, such as a vector 2 for position, which needs to be public. A draw area. That reminds me, I should talk about what our player is going to be for our level here. For the moment, we're just going to set it up as a simple white box. Simple white box. That's all our player is going to be. So we need a draw area so we can show him on the screen somehow. We need to have a layer depth. And we need to construct it somehow. In our case, all we want to do is just take in a position. So we'll write public actor taking in a vector2 of type position, well, taking in a value called position of type vector2. Gotta watch my terminology. Going to set position. Define our draw area, which word is going to make a rectangle, which is going to be 0, 0, 40, 40. That'll be a good way of showing it. And we're going to explicitly set for now our layer depth. So our layer depth is going to be equal to 0.6. Which is going to make it fit within the background item and the foreground item. Now later on in the next section we're actually going to be dynamically changing it so it'll fit in with what it needs to be, between 0.4 and 0.6. For now, just explicitly setting it. Then we need to have our update and draw calls. Let's put public virtual void update game time, which is going to do nothing for now, and public virtual void draw, taking in sprite batch that uses layer depths, and we'll just say this: sprite batch dot draw it. We're making it virtual because it's going to have some functions later on in the game when we've got our actual player character set up with our proper images instead of just using a white box. So that is our actor class taken care of. Let's look at the player class. Alrighty-o, player class. So what does it do? No extra changes into what it does for now. We'll be adding a lot more later. We'll put in here public player taking in a position, which then calls base the actor class's constructor and passes it that same position. But now, that's all it's going to do. We'll have our update call, public override, void, update, taking in our game time, which we'll need later on for animations, and we'll make the player move. So we're going to code in both the keyboard arrows for movement and the gamepad's left thumbstick. Now in the other videos, in the first ones when I was making the base game setup, I hard-coded in the keyboard and the thumbstick controls. What I'm going to be doing for this one is I'm going to be just commenting out the keyboard controls and focusing on the gamepad controls. I'll still put them in there, but they're going to be typed up. We're just going to be using the thumbstick controls as for all movement from now on. Rightio. And then we'll need to have the draw call. public override void draw, taking in sprite batch, opening up our brackets, and we're just going to call base.draw. Nice and simple for now. Okay, so that's everything we need for this. Let's stop this video, go ahead and code it into Visual Studio.